Hey everyone, it was going to be another 6 months before my next teardown video, but owing to the amount of out of balance alarms I was getting, and the fact that running bulky bedding was just about impossible on this machine at this point, it was just a sopping mess, we're going to go back in and do some good old-fashioned troubleshooting. We're also going to take some of the feedback from the last teardown video and incorporate it into this, and see if we could find out what's wrong, answer more questions, and see if we can improve upon this machine. We're going to jump right into it. Let's get started. Jumping right into service mode first to see what we got on the fault codes. And all I've collected is 31 and 26. So we're looking at one singular problem on this machine, not a multitude of issues. On the schematic in the back, we see 26 and 31 is grouped together, specifically looking at the possibilities of issues. One area is highlighted. I know it's firmly seated on the ground. I've checked this and it's worked before, so I could assume that we're going to have to check the accelerometer or its harness. Before getting underway, I'm going to clear all the fault codes, get it back to 0. If you'd like to know more about this service mode, click the link in the top right corner. I'll also leave a link in the comments below. With it cleared, I'll check, and it is cleared. There's no fault codes, and we're just going to run auto, all the tests at once. We're just going to let it run, do its thing. I'm going to speed this up really quick. We're not going to wait through this whole process. While the test is running, feel free to hit that like button down below. It really helps me out a lot when you do. Everything finished real quick at 16 times the speed. We're going to go down the list and see what the results are. So everything's green except for that FC that's red. Big red, yes. Is that fault code? Maybe. You can't click on it, so we're just going to go back and we're going to check the fault codes that we've collected. This machine has not registered any fault codes, so I'm going to go down and I'm going to select spin separately. I'm just going to run that test as a separate test. And then after that, you can see I'm going to run accelerated spin. Both of them say OOB detection is off, so none of these tests are actually going to do anything in terms of troubleshooting. But I didn't see that message until I went through the list, so that's okay. No harm, no foul. I'll check the codes again though, and there are, in fact, no fault codes. At this point, I'll be tearing down the machine just shy of opening up the heat pump. I'm not going to be showing it in this video. I have an in-depth video that goes step by step into this procedure. You can follow along in this video if you'd like by clicking the link on the top right corner. I'll also include it in the comments below. One of the devices I didn't get into as much as I wanted to in the other video was this inverter, and there are connections under here that need to be inspected. I also just kind of swung it out of the way, which could induce some strain on the cables. I don't want to do that this time. I'm going to remove this metal shroud. These two screws below will come out first. If you're following along in the teardown video, we're going to label these two screws as supplemental A and B. Lifting from an angle on the bottom, we can then lift it off the notches on the top, removing that cover. On the right side are two cables. I want to make sure they're tight. Now I'm going to be removing them shortly, but I do want to make sure that everything was tight before I remove everything. Caps like these are the reason why you wait a while after you unplug a device before working on it, because they store a lot of energy. I'll take a moment to point out that if I had a dead inverter board, I'd be checking the fuses over here and here for continuity. Another cable down here, again making sure it's tight, because we are troubleshooting, we're not just taking this apart for cleaning again. 3 small cables down here, making sure that these were seated the entire time since the last time I worked on this machine. Everything appears to be in place on this inverter board. But now that I know these cables were in, I'm going to rip them out. I didn't like the way that they were stressed last time when the inverter board was leaning to gain access to the heat pump, so I'm going to remove them outright, providing me access while at the same time not causing any tension on the cables. This one's a little hard to get to with my fingers under there, so I used a screwdriver to push the button down. At that point, I just removed this screw as in the previous video, slid this board out of the notches, and then leaned it downward, but this time without all the added tension from before. Conducting the same preparations as per the previous video, I remove the top cover of the heat pump. After we had discovered the lint accumulating in this container in the previous video, my wife had started removing the filter entirely when not using the machine, and the lower moisture content stopped all of that lint from collecting right here. Though you wouldn't see it here when the cover's lifted. You'd see it right here. This is what it looked like the first time I opened the machine after a couple of months. We could see all that lint collecting because it was wet, so the lint would catch instead of making its way to the filter. And here's what it looks like now, having removed the filter when it's not in use, allowing the top end of the machine to dry. Significantly reduced accumulation in these areas. We look here though, so much lint has leaked past from the back, and I'm going to show you why in just a bit. I did take a moment to clean up those hard to reach areas that are left of the filter as we make our way under this plastic container for the heat pump. We can see right here is our accelerometer, the primary reason for the opening of the machine today. I don't believe this one is broken, but I do believe at some point the cable is loose, probably from the last time working on it. And I don't usually stuff a camera under here while I check this, but I am checking this harness right here to make sure it's securely fit with dramatic effect because I have a camera here, but obviously it only takes a second to make sure it's snapped in. This doesn't look like a lot of room, but it could be removed if need be with one of those small ratcheting screwdrivers and a Phillips head, or by first removing the entire heat pump. Around back, we could see that cable coming up from the accelerometer by the inverter right over here, this junction where the tape is. And I don't believe it was loosened by laying this inverter down owing to all the stress relief over here, besides it's just passing through. While we're here though, we should be opening up this cover and inspecting the connections on the main logic board. So we're going to do that now. Removing these two Phillips screws. For those following along, we're going to mark these as supplemental C and D. Freeing the metal case from this white tab by lifting up, I slide down on an angle and then lower it off these two pegs on the bottom. Every connection here will be individually inspected, and all of them seem to be good. And I'll tell you that the accelerometer, labeled CN11 of the user interface board, is right there just behind the front panel and probably wasn't pushed in all the way. Here it is, the fourth one from the right. We'll test my theory on reassembly. But for now, we're going to clean this heat pump with a couple of new tricks. It starts with the general vacuuming as I have done before. But I had stated in the previous video that I'm going to do something different once it's vacuumed out, because I'm not going to use that hand spray pump bottle like last time. I'm going to use this pressurized container, and I have demineralized water, again not distilled, but demineralized. This provides for a much higher, much more consistent pressure. I could also adjust that stream on the front of the nozzle, and it made quick work and much easier work of cleaning out all of these fins of dust and debris and dirt. This idea I had in the last video. I simply didn't have the bottle or time to order it while I had the machine open, so I improvised. But it's something I did want to do last time, and I'm happy to be able to do it now so I can see what the results are of perfectly cleaning this out. Folks asked what happens to all the water I spray in it. We could see that drain right over here as I clean up the final remnants that blew off the fins from the sprayer. The fins look absolutely brand new. I'm just going to post a picture here before and after so we could see. The pump spray bottle is definitely the way to go. If you want to see how lint is getting past this filter, look no further. We're going to install it while the cover's open. And I'll point out, because the top is not on, obviously there's no top track. Be that as it may, perfectly seated, we look at the back and look at all the slop that's in the back. Even if it was centered, there's so much gap. I don't know what the purpose of that back piece is with that air gap, but all it does is allow crap to blow behind there where it usually collects, through and in those fins that we saw, where it starts the dirtiest towards the rear and tapers off as it makes its way to the front. The front area here, we see there's a seal, and it's fine. It doesn't look like anything would get past that seal in the front. But the back is absolutely terrible, and it serves no purpose. But that's the problem. I feel like I want to get a piece of high temp foam and fill that back area so this could press against it. Doing so would probably mitigate a lot of these issues. And that deep well is only on the bottom half of the cover. As we see on the top, it doesn't exist. It's a lot more shallow, so I don't know what the purpose is. Here's a view from the last opening. We could see it blowing straight through that notch and collecting right over here. What a terrible design. Going to begin the assembly portion now, but I am going to cover those extra areas. Having reinstalled the inverter, I'm now going to reconnect these cables after they're dressed in, snapping in for a positive connection. Then I'll dress in that second cable up top and connect that one back in as well. Having reconnected the inverter, I'm going through and making sure that all of these connectors are seated properly, each and every one. Satisfied with the connectors, I can place that metal shell back on, first on the top on an angle to seat those two white pieces, placing it back down. There are two pins that seat the bottom, and we'll be using screws A and B. And like in the other video, just putting in the screw about 3/4 of the way until the second screw is in, and then seating that one fully, and then going back and forth to snug them down. I'll be re-inspecting all the connections on this board just for good measure before putting the cover back on. Everything seems good. This cover will first lock in those tabs from the bottom, and then swing around from the top, snap in a position, where it'll then be secured with screws C and D. Again, 3/4 of the way on the first screw, onto the second screw all the way down, and then snug both back and forth. As I see targets of opportunity, I go and make sure the connector is fully seated. I also go through and check the solenoids here in the rear. There are several plugs. I just make sure that they are all the way in. And these are good. And there is one cable tie that was removed here for these two cables. I'm going to add that back right now. And finally, the last once over to include the accelerometer under here, as well as a general inspection of all parts, pieces, cables, tie downs. Everything looks good. And paying very close attention as I reconnect and redress all of the connections on the front panel, remembering that position 11 is the accelerometer and might have been loose from last time's teardown. We can see that accelerometer connection right here, and that may have been the cause of all my trouble, just right over there, no further. Though this teardown did present the opportunity to find some other problems, another session to clean out the heat pump, and more interesting information about the filter. So yeah, definitely not a waste of time. But we're ready to see if the work paid off. So let's run it. First thing I did was run the auto test in the diagnostic all over again, just to make sure that everything was working fine. I do pay close attention to the numbers on the heat pump after I do a clean out, make sure everything is working nice. Monitoring the heat pump values during the entire test, and yeah, everything is looking good on the heat pump. Let it run through the rest of the test undisturbed, and then once it did, I went through all the values, and everything was green saying complete again, except for that one value, FC, fault code, whatever, yes in red, you can't do anything with it, so whatever. If it failed any of these tests after you open the machine, you did something wrong, you gotta open it again. We're doing good, so let's move on with an actual practical test. And we're doing the Lily double bed test, which is loaded the same way in the machine every time, and this worked until it didn't, and we're going to try it now to see if it works yet again. One bed is loaded centered, the other bed directly in front of it. Here's how it looks from the front. We're going to get started with the settings, and this is going to be bulk bedding on extra heavy. Also, we shut off the fabric softener on Lily's laundry, so we'll do that now. We'll be shutting off the dryer as well, and we hit start. A good portion of this time is going to be uneventful for our test until we start getting up to some spinning action. Around this time you start to see some spinning, but we're not talking about the ultra high speed. It's enough to let us know that things haven't failed up until this point. You hit a certain frequency where the machine does shake a bit, not terrible, but it's almost unavoidable, but as it speeds up that shake will subside. So if it is balanced, it does shake a little. We found that shake did get worse once the pedestal was installed, but as long as it's not interfering with the machine, it just shakes a little, it doesn't really bother us. It shakes right here, and then it's gone. I imagine without the pedestal, that little shake wouldn't appear at all. It spins at the lowest speeds where it sits right there as it shakes. I imagine it could also look like it's shaking quite a bit.
After the wash, it would stop and not spin, and it would all be sopping wet and just do what it's doing right now, a slow spin. It wouldn't speed up.
I'm told when it would fail, it would attempt to start spinning, and it would only do a slow spin and never actually speed up. We'll use that scene right there to demonstrate that, but it didn't actually fail because it is winding up. It does do those slow spins as part of its normal process.
Thank you, sir.
You're welcome. Happy wife, happy life. And we can hear it churning now. It's running at the second highest speed that it can run at, almost at full tilt. We can see that there is no vibration whatsoever on this machine. So as long as the machine is level and the feet are set up correctly, there shouldn't be any problem except for that little oscillation inside at a certain speed. But it shouldn't happen the entire time. Lily shows up for the grand finale where it's about to go full tilt. This is that last 2 minutes where the spin tries to get all the laundry as dry as possible. If this fails, you will have wet laundry no matter how long you run the dryer. Here we go. And that is the full tilt spin cycle, pulling all the rest of the water out of the laundry. If you got an imbalance and that is never achieved, the laundry would just be soaking wet. And that's why a lot of people are complaining that they have wet laundry when they open the machine, because this cycle never happens. And that's where the whole process starts to come to a close. That's a repaired washer in my book. We're going to pull these two enormous beds out one at a time and have a look. Almost right. We need Lily's approval.
You approve?
Lily approves. Yeah, it's all clean, huh? It's also mostly dry. Pull out the other one. Not only these beds coming out smelling perfectly clean, and you could see how they fill up the entire volume of the machine, they're also coming out almost entirely dry because the spin cycle is now working properly. So by following the provided schematic to conduct standard troubleshooting procedures, making sure that wire was connected, along with all other wires and connectors that were available to us, along with the ability to identify components that could be the cause of failure, as well as learning from and improving upon our previous cleanout, we're able to bring this machine back to like-new operating condition. All the while discovering why our filter design is so terrible and why our heat pumps are failing prematurely. And that concludes this video on the troubleshooting, repair, and engineering problem discoveries, as well as improved heat pump cleaning techniques with this GE 2-in-1 profile washer and dryer. I hope you found this video enjoyable, entertaining, and informative. Do me a favor, hit that like button down below, helps me out a lot when you do, and hit that subscribe button for more videos like this when they come out. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?